Hey guys, hopefully you watched this whole video start to finish because I'm walking you through your test right now, which is tomorrow. So make sure you get this stuff. If you don't, ask your neighbor. Someone around you probably could help you out if you're not sure on it. And then you have the rest of the class to work on the chapter review assignment. So here we go. First thing you're going to do on the test is tell me what's a hypothesis and what's a conclusion. So they tell you underline the hypothesis once and the conclusion twice for each statement. So for this first one, if an angle is acute, then its measure is between 0 and 90. Your hypothesis is the if portion, but not including the if. So your hypothesis would be an angle is acute, and your conclusion would be, so double underline this, its measure is between 0 and 90, okay? And notice I didn't underline the if, I didn't underline the then, so leave those ones off. Second thing you need to do is find a counterexample, and a counterexample is where, let's say you have if P then Q, okay? Whatever your statement is, we want this P part to be true and the Q part to be false. So, for instance, in this setup, if I play basketball, then I am a point guard. So we are looking for a basketball player that is not a point guard. So you have some options. You could say a center, right? That's the big guy down at the bottom. Or you could say a forward, or you could say a bench player, like someone who sits the bench. But that would be a counterexample. A counterexample is just going to be a one-word answer, or maybe a couple words, depending on what the scenario is. Second one, if it's not Monday, then it must be Tuesday. So we're looking for a day that is not Monday, but is also not Tuesday, right? So a counterexample might be Wednesday. But again, could be Thursday, could be Friday, could be Saturday. You have a lot of different options for your counterexample. I just need one, okay? All right, so that's finding a counterexample. Then we get to these guys, converse, inverse, and contrapositive. So I'm going to give you a conditional statement. I'm going to give you an if-then. And then we're going to write the three different converse, inverse, contrapositive from that. One thing to keep in mind, and I'll just write this on the side over here real quick. The conditional statement is always if P, then Q. Okay, that's your conditional. The converse just switches those. If Q, then P for the converse. The inverse goes back to the original and negates both parts. So that would be if not P, then not Q. And then the contrapositive takes the converse of that. If not Q, then not P. Okay, so that's your setup for those. Remember, you can always go back and rewind if I'm moving too fast, or pause it. That's totally fine. All right, so here it is. The conditional statement says, if you eat a whole bag of candy, then you will have an upset stomach. Generally speaking, I would say that is a true statement. Okay, so we're going to call that true. The converse of that is just going to flip our if part with our then part. So this would say, if you have an upset stomach, then you ate a whole bag of candy. Okay, so we got to think, is that a true statement? If you have an upset stomach, then you ate a whole bag of candy. I would say that is false, because you can have an upset stomach for other reasons. For instance, a counterexample might be you have the flu. You didn't eat a whole bag of candy, you just happen to have a flu. So that would be false, and your counterexample would be the flu. Okay. The inverse then is going to go back to this original conditional and negate both parts. So if you don't eat a whole bag of candy, then you won't have an upset stomach. So let's think of it like this, okay? We didn't eat a whole bag of candy. Is it possible for you to still have an upset stomach? And the answer would be yes. So this is a false statement. And again, because you could have the flu and get an upset stomach, even if you didn't eat a bag of candy, you can still get that upset stomach, okay? Notice the converse and the inverse will always have the same truth value, false and false, or true and true, okay? And then the contrapositive is going to take that last statement, that inverse statement, and reverse it, take the converse of it. So if you don't have an upset stomach, then you didn't eat a whole bag of candy. Okay, and I would say that one is true. If you don't have an upset stomach, chances are you haven't eaten a whole bag of candy recently. Because if you ate a whole bag of candy, you would get an upset stomach. So that would be a true statement. And again, notice the contrapositive and the original conditional, those are both true. So contrapositive and conditional will always have the same truth value. Converse and inverse will always have the same truth value. Okay, and if it's true, you don't need a counterexample. All right. Then patterns. Let's say we have this setup. It says describe the pattern and find the next two terms. So you're asking yourself, how did I get from 4 to 8? How did I get from 8 to 10, from 10 to 20, from 20 to 22? 4 to 8 might be plus 4, or it might be times 2. Okay, to get from 8 to 10, we're not going to multiply something to get that very easily. So that one's probably just plus 2. Okay, then to get from 10 to 20, you could add 10, or you could, multiply by 2. Well, if you look back to your first one, and then here's your third one, both of those were times 2. So chances are we are doing times 2, and then plus 2, then times 2, then plus 2. And the pattern just keeps continuing. So your pattern would be times 2 plus 2. Okay, which means your next two terms, if the last thing we did was plus 2, then we need to do times 2. So 46 times 2 is 92. And then for the next one, we need to do plus 2, which would be 94. Okay, so that's patterns. Just looking at what is the pattern and what are the next couple terms for that. Last few. This one says, use the law of detachment or the law of syllogism to draw a conclusion. If you can't draw a conclusion, write not possible. Okay, so we're going to look, I'm going to make it a little bigger so we have a little more room here. This first statement says, if a person is a musician, that's our P, then he can read music. That's our Q. Okay? Remember we said it has to go if P then Q, and they have to tell you P is true, and then you can say Q is true. But if that's not the flow of it, you have to say not possible. Okay, so if you look at this setup, if a person's a musician, then Q, he can read music. And it says George can read music. That's your Q portion. So they did not tell us that P is true. So for this one, because they didn't go back to the P right here, you have to say not possible. Okay. This second one says if two angles are complementary, then their sum is 90. And it says A and B are complementary. So this is if P, then Q, and they gave us that P is true. So if you look at this flow again, you need if P then Q, and the P portion has to be true. We can then say angle A plus angle B should equal 90. Or you can say angle A and angle B's sum is 90. Okay, either one of those would be an acceptable answer. These are the angles we're talking about, so we want to keep that in our answer. You don't want to just say their sum is 90. But angle A and angle B's sum is 90 would be a good way to say it. Okay, so that's law of detachment, both of those. Law of syllogism is the one where you cross out what's identical. So if it's snowy, or if it snows today, then I will wear my gloves. And if I wear my gloves, then my fingers will get itchy. Okay, well, the two that are identical is wearing gloves. So if we cross out the wearing gloves statements, what you're left with is this statement. If it snows today, then my fingers will get itchy. Okay, and you would just write that if-then statement. All right, and then last one, and then you'll have the rest of the time to work. It says write a biconditional for this statement. So in order to write a biconditional, you have to be able to say it both ways. So if x plus 2 equals 7, then x equals 5, or flip it around. If x equals 5, then x plus 2 equals 7. Well, no matter which way you look at that, they're both true. So if they're both true, then what we do is we take out the if, we take out the then, and we turn it into an if and only if statement, right? We write that as IFF. So we're going to say x plus 2 equals 7 if and only if x equals 5. Okay, so that would be your biconditional. Take away the if, take away the then, put in an if and only if. Okay, and that pretty much does it for the test. If there's anything you have questions on, ask someone around you. I'll be back tomorrow. You can ask me some questions then before the test, but the test is tomorrow. So make sure you are good to go on all that stuff today. And then you have the chapter review for homework, and all the answers for that are in the back of the book, so you can check your work if you're not sure if you're doing it right. Okay? Have a good one, and I will see you tomorrow.